Happy Valley in Hong Kong is a low-lying area surrounded by hills on three sides. During heavy rainstorms, runoff from the vast uphill catchment caused flooding at Happy Valley and its adjoining coastal districts, seriously affecting the life of the residents. The coastal areas in Hong Kong are highly developed and bustling. It is difficult to carry out large-scale excavations to improve the drains to prevent flooding. To solve the flooding problem, the Drainage Services Department of the Government of the Special Administrative Region constructed drainage tunnels at the upstream of the urban area to intercept runoff, as well as implemented this underground stormwater storage scheme in Happy Valley. The scope of this project includes a 2.4-hectare storage tank with a capacity of 60,000 cubic meters, a newly constructed box culvert connecting the upstream and downstream existing drains, movable weirs, a stormwater pump house and a fan room, etc. During heavy rainstorms, stormwater runoff is temporarily stored in the storage tank, relieving the downstream drainage system. Different from the traditional storage tanks, this project features numerous innovative designs, including movable weirs, water harvesting system, and opening up the at-grade space of flood prevention facilities in a site-specific manner for public use. These designs echo the concept of Sponge City to promote sustainable development. The first underground stormwater storage tank in Hong Kong is hidden underneath Tai Hang Tung Mong Kok in Kowloon, with a capacity of 100,000 cubic meters, solving the prolonged flooding problems in the vicinity of Mong Kok. The Tai Hang Tung stormwater storage tank adopted the traditional fixed weir design that allows stormwater to overflow into the tank only when the water level is higher than the weir level. As such, stormwater may spill into the storage tank earlier than the design requirement and preoccupy the tank's capacity. Therefore, a larger storage tank is required to achieve the same drainage capacity. Since more stormwater is collected, additional pumping energy is needed for discharge. Meanwhile, the cost of desilting works is higher. All stored stormwater has to be discharged by water pumps. The traditional fixed weir cannot be easily adjusted in response to the change in rainfall intensity and increase in sea level due to climate change. In order to collect stormwater runoff more effectively, the Drainage Services Department has worked collaboratively with Black & Veatch Hong Kong Limited and the Hong Kong University of Science and Technology to install movable weirs at the Happy Valley stormwater storage tank to collect and discharge stormwater that works in connection with a real-time supervisory control and data acquisition system. The system makes use of 3 water level sensors at the upstream, downstream and within the storage tank to monitor the water level in real time and automatically adjust the level of the movable weirs so as to control the time of stormwater overflowing into the tank. The system also reads the sea level measured from the tide gauges. When the sea level is high, the weirs will automatically close to prevent backflow of seawater into the storage tank.
To further study the operation mechanism of movable weirs, this project not only adopts the two-dimensional hydraulic model for assessing the hydraulic performance of the drainage network, but also established a three-dimensional computational fluid dynamic model to simulate the flow conditions at 4 converging locations, such as the Stirling Basin and movable weirs. After detailed research and investigation, the project team integrated the use of penstocks, water level sensors, and computerized supervisory control and data acquisition system as the key technology of the automatic and smart movable weir system for control of stormwater inflow to the storage tank. The movable weir system allows excess stormwater to enter the tank at the optimal time, and also enables the discharge of part of the stored stormwater back to the box culvert by gravity instead of pumping to achieve energy saving.
The innovative movable weirs allow the Happy Valley stormwater storage tank to flexibly cope with various rainfall conditions, effectively reducing the size of the tank by 1/4, saving construction costs and time. Fully utilizing the drainage capacity of downstream drains to avoid early overflow and reduce associated maintenance and desilting expenses. Reducing pumping energy by 30% through discharging 1/3 of stormwater by gravity. Coping with changes in rainfall intensity and increase in sea level due to climate change with movable weirs to better realize the concept of sustainable development.
In view of the hilly terrain at the upstream of Happy Valley, the success of this design relies heavily on the diversion of the very high velocity supercritical flow smoothly and stably to the downstream storage tank underneath the horse racing course. We developed a 3-dimensional CFD model as well as a physical model to simulate the complex fluid mechanics at the flow converging locations, so as to avoid unwanted hydraulic jumps, flow separation, air pocket formation, and negative pressure. For example, the Stilling Basin built at the upstream of the storage tank allowed a controlled hydraulic jump to occur to convert the fast-moving flow into subcritical flow. We also made use of the physical model to determine the flow coefficients, the discharge coefficients of movable weirs for design of its opening height under various rainfall conditions. As a result, we developed an operating scheme that is able to adjust the weir height as a function of the rainfall conditions as well as downstream water level and tide level, thus enabling the storage tank being utilized at the optimal time.
After completion of the design, various enhancement measures were implemented at the construction stage, including setup of building information modeling to enhance the construction process, use of smart system to enable real-time monitoring of the storage tank condition through mobile devices, provision of an uninterrupted power supply system to the movable weirs so that the weirs can still be fully opened in case of power outage to deal with various emergencies. The project team also uses wireless sensors to record the water levels and runoff velocity to calibrate the shape and time of peak flow predicted by the computer hydraulic models to enhance the efficiency of the weirs. Stage 1 of the Happy Valley underground stormwater storage tank and movable weirs were commissioned in March 2015 and have protected the city from flooding multiple times since then. On the 19th of October 2016, the total daily rainfall in Hong Kong reached 223.4 millimeters. With the effective use of the stormwater storage tank for flood retardation and storage, the threat of flooding in the previous flooding black spots in Happy Valley were eliminated. That day, horse races were held within 2 hours after the heavy rainstorm as scheduled. Apart from the movable weirs, the storage scheme adopted an innovative foundation design to make good use of water resources and promote sustainable development in the city. Happy Valley is adjacent to Victoria Harbour with a very high groundwater level. Traditional design scheme adopts piling foundation to fix the location of the storage tank. The Happy Valley underground stormwater storage scheme adopted an innovative foundation scheme that comprises peripheral sheet pile wall and subsoil drainage system to replace the original 533 socketed H-pile. This design can control the groundwater level beneath the storage tank, preventing the tank from floating due to the flotation force acting on it. This scheme didn't only reduce the construction cost by 72 million Hong Kong dollars and construction time by 3 months, but also lowered the emission of carbon dioxide due to the piling works by 88,000 kilograms. Besides, DSD adopted the site-specific design approach, making good use of groundwater collected from the subsoil drainage system, and constructing a water harvesting system with a current maximum design daily supply of 600 cubic meters of harvested water. Apart from utilizing the subsoil drainage system underneath the tank to collect groundwater, subsoil drainage system and porous paving units were installed on top of the tank to allow collection of surface rainwater and irrigation water from pitches. As these water resources are of good quality, by simply adding bleach solution, they can reach the required standard of grey water reuse. The stored water resources will be used as flushing water, irrigation water, as well as cleansing water for streets and buildings in the vicinity of Happy Valley. In addition to meeting practical uses, modern infrastructures need to blend in with the environment. The Happy Valley Underground Stormwater Storage Scheme adopted various green and energy-saving designs. Meanwhile, the at-ground space of the stormwater storage facilities is open for public use. The rooftop of the pump house has been turned into a green lawn. Apart from being a drainage infrastructure to relieve flooding, the pump house provides new recreation space for the public. The project team maintains close liaison with the public and has received a number of local and overseas professional institutions, attracting wide coverage from the media.
In Hong Kong, the hilly terrain, limited supply of land and space, as well as dense population along the urban coastal strip, have posed huge challenges to flood prevention projects. DSD always embraces innovation and has a mindset for change. The Happy Valley Underground Stormwater Storage Scheme innovatively enhances the flood protection level of the city, solving the flooding problems in Happy Valley and Wan Chai district. The adoption of smart and automatic movable weirs, water harvesting system, and green building designs has created a more resilient and adaptable drainage system that blends harmoniously with the environment. With the project team's dedication, the project was completed 14 months in advance of the program with a saving of 90 million Hong Kong dollars, accounting for about 8% of the project cost. This project has attained significant economic and social achievements. Not only has it become an exemplary model for NEC projects in Hong Kong, the mainland and overseas, but also an excellent example of realizing the concept of sponge city. Each and every drop of effort for the public is our watchword. In the future, DSD will continue to optimize the use of land, as well as explore more innovative and practical ideas in our designs in order to make Hong Kong a more livable city.